Hello, everyone. Welcome to the meetup. I really hope that you will enjoy it. Our backend engineers, they regularly talk about Manychat's production stack and how we push PHP to its limits while operating on pretty modest resources. And today I would like to share with you the high-level helicopter view of the entire Manychat system evolution, how the platform grew from the very beginning, what issues we faced, and how we actually solved them, and how we kept adapting to continuous changes in the load patterns. Hopefully, let's keep our fingers crossed, this will inspire you to explore PHP's full potential, and take a look at how it's possible to scale and optimize high-load projects without, let's say, deviating from the tried and tested approaches that are well known to the industry. Again, I'm Alex, I'm a backend lead in one of the product areas, and I joined the company 1.5 years ago. And to be honest, I was not the part of the inception of Manychat, and I was not the part of the major things that I'm going to be talking about, but I was really inspired by the story when I first joined the company, so that's why I'm here to share it with you, and I hope you also love it. Before we write here, how many of you have heard of Manychat? Please raise your hands. Wow, that's a decent number. For the rest of the folks, I will still build some chain with a description of the product to build a foundation for you to understand what we are actually about, apart from the previous intro, so that you know why some certain decisions were made. So, as I said, Manychat is a chat marketing platform, and businesses use Manychat to automate their conversations with the customers. And if you use Instagram, you might have seen some call to actions like, hey, comment under this post the word link, and then I will share the link to my product into your DM. These call to actions, they actually trigger some automated scenarios, automated chains that are actually powered by Manychat. So on the screenshot, you may see that if I first interact with an Instagram account, let's say I will comment under the post, then I receive the welcome message like, hey, here's a cool resource you might like, some of the buttons for me to engage with the business account, then I pick some option, then this conversation chain continues, leading me to some sales point. So this is what the Manychat is about, to provide this automation tool. And from the business perspective, businesses actually use Manychat to create these conversation scenarios. And this is one of our core components, the flow builder. It is actually the heart of the system. And I would say that this flow builder, this is a tool that serves as an intuitive and flexible no-code programming tool for our customers to quickly design this conversation workflows and chains. This is just an example, but let's say we start with a user comments on your post to reel, then set the greeting message stands for commenting, then wait a couple of seconds to make it a bit more engagement. Then ask for some relevant data. When action on reply, when that is provided, you can send it to another automation or save for the future users, set the delay after 1 day, do some things, and etc., etc., etc. So in general, this is a very flexible tool where our customers can create these conversation scenarios. And overall, with that said, let's take a look first on the overall scheme of interaction with Meta company. So our channels that we support right now, they're Instagram, Facebook, WhatsApp, also TikTok, but I will be talking mostly about the Meta part. So first of all, customer over here interact somehow through the Meta application, through the Instagram with the business account. Then Meta company sends Manychat the webhook containing this information. Then Manychat accepts the webhook, identifies what should be response to the subscriber, and send it back to Meta to the send API. So it's kind of in a loop. We receive the message, we identify the response, we send it back. This is how this automation is powered. And the business representatives on their side use Manychat through web application or our mobile application to configure this automation. So overall logic, I believe, is pretty straightforward. When I was talking about the webhooks, so here's an example of a single, again, spoiler alert. This is an example of a single webhook. So pretty much it's just a simple JSON payload that contains information about the type of interaction, the recipient ID, and the sender ID, so we can identify which business account interacts with another one. And overall, for Manychat, the webhook processing, it is one of the core components that we have because it enables communication between business and their users. And if we imagine that this component slows down or even fails completely, it will mean that businesses, they will lose their customers, they will lose the trust, they will lose the money, so it's going to be a complete disaster for the company. And I would use specifically this webhook processing part just as an example to illustrate how a service architecture evolved over time. And before doing that, for simplicity, I'm going to use two terms. So with subscriber, we will call the end customer of the business account. It could be me, it could be you interacting with the business account through Instagram, Facebook, and other channels. And with the bot, we will call the collection of entire automations of one single business. So single business can create various automations. All of them, it's going to be called just like a single bot. And the tech stack, once again, at its core, it's PHP plus Nginx. As our main database, we use a PostgreSQL. Then we use Redis, Elasticsearch, and all of that is running on top of the AWS. All right. With this said, let's go back in time and start our story. So it started like almost 10 years ago. Really huge, isn't it? Within the first months after a successful announcement on Product Hunt, Manychat acquired its first users and reached like 2K bots and 7K subscribers. And at this point, the only ability and the only support was for the Facebook Messenger and the only ability to automate conversations in the Messenger, so just the messages inside the Messenger. And the architecture looked this way. I hope it's clearly visible to all of you. If not, please raise your hand. I will use the spotlight. So pretty straightforward. The webhook request is handled by Nginx, then it transferred to PHP FPM, which loads our YE application at that moment. Then the actual code do the processing, identifies the response, and sends it back to Meta through Send API. Pretty straightforward pipeline. Almost immediately with this pipeline, we ran into the first serious issue. The thing is that Facebook Send API is relatively slow. So with some requests to send the message, it could take like seconds. If one single webhook triggers a couple of messages to be sent, it could be dozens of seconds. At the same time, on the other side, when the Meta is sending this webhook, it kind of expects our service to respond quickly under milliseconds. Otherwise, it starts to throttle, I would say, and eventually it could even block your application from the webhooks just because it starts to think that you're kind of the cause of a lot of errors for your end users. And the solution here was simple. So we just began to close the connection with HTTP 200 code just immediately after the initial validation of the webhook. So once the webhook is validated over here, we close the connection, send the response back to Meta, and this gives us plenty of time to do the actual processing of the business logic in the background, let's say. A good example of Manychat's efficiency before innovation approach, so without drastically changing the entire solution, we were able to solve the initial issue. By the end of the year, Manychat expanded to 10K bots that was serving more than 700K subscribers. And in the meantime, we released two major features. So first one, the live chat component was introduced, and it gave the ability for businesses to send the messages to their customers directly through Manychat platform. So there is no need to go and open Instagram application to send the message. And the second one, we started to aggregate the statistics on the actual delivery and whether the message was read. So we started to collect some data of the messages. And with these features, it means that we started to receive 4 webhooks instead of just one per one single message into Facebook. So the load increased dramatically over here. And again, with only 2 backend engineers at that time, the Manychat team didn't want to really overcomplicate things. So ultimately, the solution was to split processing into separate streams. So the actual message was sent directly to webhook processor, while the rest that belongs to live chat or that belongs to the statistics, and they are kind of less time sensitive, they could be stored in the database and then processed at their own pace. So pretty straightforward again. Moving next. So fast forward just 6 months, and Manychat rapidly grew to over 7 million subscribers. And meanwhile, our clients right now could interact with customers not only through the DMs, but right now we support any type of interaction with a Facebook feed. So every post, every like, every comment under the post, everything is there. So that's why the load increases dramatically, just because we start to receive a lot of webhooks over here. But this is not the end. So one day, a Katy Perry day happened. For those who doesn't know Katy Perry, she's a famous American singer with a lot of fans around the globe. And just imagine how many subscribers she could have back then on Facebook these days. And one day, actually it was the night during the European time, the SMM team of Katy Perry launched the Facebook bot on Manychat and posted the announcement to subscribe to it. And in a single moment that day, which we will never forget, the peak load increased 4 times. Actually, at this point, I believe it was just like a cold shower for the Manychat team, which helped to realize that every engineering decision that we are going to do moving forward has to be planned with scalability in mind. So we need to think when we need to ensure sustainable growth, we need to think of the decoupling of some certain parts of the core components to be able to refine, upgrade, scale them independently without any consequences to the entire system. And the one solution that may come up to your mind is just to separate with some kind of a queue system the part that starts at receiving the webhook and actually making the processing of it. So we decided to implement the proper solution with queues, and to do this, we chose Redis. And throughout the years, it proved to be an excellent strategic decision for the company. So we've managed not only to leverage the power and simplicity of Redis for this initial task with the implementation of the Cascade queue system that I'm going to be talking a little bit later, but we also used Redis as a tool for the bunch of tasks, actually, for caching, locking, monitoring, introducing other queues based on Redis. So right now, our Redis cluster handles more than 1 million requests per second. An interesting number to support. So first solution. In our first solution, as I said, we replaced synchronous processing line between the webhook controller and the webhook processor with the queue system. This made distant parts of the system more independent and individually scalable. And since we increased the webhook inbound capacity, we needed to add multiple workers to be able to process all that webhooks that we receive. It's called other, but it's actually main. It's the main queue when we receive all the messages. And this solution has its drawback. So the message queue, on the one hand, it could contain messages, the webhooks from different subscribers. But on the other hand, in some certain occasions, it could contain messages from a single subscriber. So it's going to be like, hello, how are you doing? What's the price of your product? And the thing is, if each message is processed by a separate PHP process, it means that one process that is processing hello could be slower than the other one that processes what's the price of the product. The result of this is going to be that we respond to the subscriber in the reverse order. It's going to be 100 euro, yeah, hello to, nice to meet you here. So it doesn't make sense. And the idea is that you may think that it's kind of an issue that could be tolerated for some reason. But at the scale that Manychat had these days, it was a real issue to the system. So we really need to think about it properly. And again, Redis again saved us and came to our rescue. So we chose an approach where each bot, so each business account gets a dedicated queue. This way, only one process at a time can handle messages of the specific business account. And just to be efficient in our computational resources, we didn't want to overspan workers to make this one bot, one worker. That's why we introduced the control queue. That's the idea. So when a new subscriber message arrives, let's imagine that here's the message, we publish 2 messages to the queues. One goes to the control queue, which is bots. And this message signalizes that this particular bot ID has something to be processed. The actual message with the payload from the subscriber goes directly to the queue of this bot. Let's imagine it's bot number 2. So then, whenever we have a spare PHP process that we can span, first, it goes to the bot's queue, it retrieves the bot ID that has something to process, and then this process kind of assigns itself to the specific queue. In this case, to the queue number 2. And starts processing the messages from this particular queue of only one business. This solution actually not only resolved our initial problem, but also eliminated the noisy neighbor issue. When a business, like in Katy Perry case, suddenly experiences a spike in traffic, in the previous solution it means that we kind of block the common channel. So there are a lot of messages from one single bot, and there are less messages from others. So we're kind of prioritizing this way the Katy Perry case. But with this solution, it's no longer an issue just because every bot gets its own dedicated processor, and the activity of celebrity neighbors, it doesn't affect the latency and the response times. And moreover, this approach also scales easily. So when we see that the control queue is kind of filling up with tasks that we are not able to process, we can dynamically adjust the number of workers that work with them. Next milestone. By early 2018, our audience had grown several times, and we've reached the milestone of 1 billion messages sent per month. The average load of the system at this moment was 5K RPS, and we are not counting here any celebrities. We're happy with Redis, it serves well, all good, but at 5K RPS, PHP FPM was no longer able to handle the load effectively. And we started searching for a solution. So we researched the market and noticed the growing popularity of the synchronous processing in PHP, and actually stumbled upon React PHP. I'm not sure that it's visible over here, but with this solution, we kind of replaced PHP FPM with React PHP without introducing any major refactoring to our processing part. We first conducted quick tests, then do the POC, and eventually, we fully replaced PHP FPM with React PHP over here. Initially, we started with 4 instances of React PHP and eventually scaled up to 30. And actually, for quite some time, this became our primary solution to scale and to handle more incoming load. But when we talk about React PHP, we kind of increased the incoming funnel of webhooks, so we can accept more and more webhooks. And at this point of time, we start to experience the bottleneck in the processing part and actually on the data layer. So what did we do? Another solution that may arise in your head is just to do the partitioning of data. That's exactly what we did. So we took all bots. This is the part of the processing, actually. So again, spoiler alert. So we're talking right now in terms of the processing somewhere over here. So it's this part. And in this part, we took all bots and distributed them evenly across clusters. This led to the creation of what we call a galaxy. So a galaxy over here, it's both a physical and logical partitioning over the processing. So each galaxy contains a certain number of clusters. Each cluster contains all the data that is related to its cluster. So from the technical perspective, the galaxy consists of one single Postgres database server instance, one single Redis instance, and one instance of our application. So from the database standpoint, if we take a look at how the Postgres will see it, we have a physical scope and sense. So each cluster has a dedicated database, and then the Galaxy just is a server that handles all this database of the cluster. As for the Redis, in Redis we contain all the queues and all the related data for clusters over here. In Redis, there are no physical boundaries, I would say, so we just separate the data in a logical way. And in a nutshell here, every bot from now on was correspondent to a specific certain cluster. And React PHP over here, at the very beginning, it has an access to the information to which particular cluster each particular bot corresponded to. And once we receive the webhook, we can easily propagate this webhook to some certain cluster and process it in the limited scope of the cluster. This approach actually demonstrated really great load resilience, and we quickly realized that, I love this metaphor, that while Manychat universe is expanding, we can create more galaxies to it. Nowadays, we have 6 galaxies in production, each with around 10 clusters. Next milestone, 2018, September. The number of subscribers reached 200 million. And at this point, I believe that it's hard to estimate the scale of the SaaS platform, but just to put the scale into perspective, try to imagine managing the website with 200 million active users. And webhook in general, this is controversial, but webhook in general is a relatively simple task, and PHP is not the best tool to handle single small units of tasks. Even React PHP struggled to handle the load of 10K RPS, experiencing memory leaks, and etc., etc. Again, we started to look for another solution. And the solution is actually over here. So we discovered OpenResty. It's an Nginx distribution. By default, it offered Lua support and also included a library for the direct integration of the connection of Redis into this. So sounds like a perfect fit to our design since we use Redis and we rely on Nginx. And the first Nginx configuration example was written just in 3 hours as a POC, and it contained like 50 lines of code. And eventually, everything that React PHP with 30 instances of it was doing now is able to do just 50 lines of code of Lua script. And this is how the architecture was transformed. So on the left, we start with no OpenResty, then it rolls to the specific Redis queue, the incoming webhook, and then it's kind of the task of the inbound processor to redirect to the clusters, do some pre-processing, etc., etc. We continue to handle the load effectively and again focused on the business growth and new features. And this is an example of the Lua script. You may copy it, it's just an example, but for some reason at the very moment it doesn't work. So we we parse the body from the request, it's just a validation. Then we calculate the hash to be able to distribute, let's say, evenly between the available shards. Then we do the Redis, we require connection, we do the connection inside the Lua script. If not okay, then of course we exit with 500. Then we simply push the message to the queue, and this is pretty much it. And then Nginx says okay.
Open here.
The next major milestone came in 2019. The number of bots exceeded 1 million, with our subscribers base reaching 500 million. And we continue to enhance our Lua-based solution. By the way, I forgot to mention 25K RPS. That's actually the highest peak so far in our history. We continue to enhance our Lua-based solution, but briefly, what we did here is we kind of retrieved the knowledge about whether this webhook should be redirected to the statistics system, or whether it's about read the message, something like that, or whether it contains the actual message of the subscriber and it could go straight to the processing. So it was just added like in 20 lines of code and in Lua scripts. And right now it may appear still straightforward and easy to follow at the first glance, but at the same time, it is a complex system right now with distinct units that operates independently from each other and allow us to scale them independently. And of course, each of the components is very sophisticated enough to deserve another topic of this, but we are on the bird's eye view, so we continue. 2020 to the present, and you may ask, what happened? Now it's 10K RPS. How come we are slowing down in terms of the RPS? And in 2020, everything's changed when Meta introduced 24-hour window rule. So previously, businesses could communicate throughout like a week or something like this. But right now, with the introduction of this rule, where the business no longer able to send the message to the customer out of 24-hour window. So once the customer engaged with the business, it opens the 24-hour window. After that, no way we can reach back to the customer. So it drastically it changed the market entirely, but it drastically changed the load patterns that we have. But it was an opportunity to Manychat, actually. So we kind of shifted our focus from the squeezing milliseconds from the inbound webhook processing to more sophisticated business logic that we offer to our customers. So we started to connect a new channel, Instagram, WhatsApp, and TikTok. We introduced numerous opportunities for external integration. So from now on, you may have your own CRM where we are able to provide your integration. So after the email is collected, you can send it to the integration. We also started to work on AI features, and we are pretty on a hype here. And we focus on attracting more users, building the community, and trying to educate people to build more sophisticated automations. So all of this changed the focus to business logic optimization and the way how we process the webhooks instead of just accepting them as much as possible. And to the right, since we're running out of time, to the right there is a talk that from our infra engineer about how we actually do the synchronous processing in PHP in our way. Just because with a lot of external integration and external requests, we need to leverage the computational resources over here. We need to fire a lot of requests, but in the meantime, we have a lot of things to be processed. This is the talk about how we actually do this. And the left QR code is just the same topic, but in an article format on Medium. So if you'd like to revise it later, feel free to do this. And just a little recap. So we started with 10 RPS, Nginx plus PHP FPM, pretty straightforward file and the pipeline. Then we introduced like a separate storage, let's say, queues for some type of webhooks and stored it in Postgres. Then one day, Katy Perry Day happened, which introduced us to Redis and the queue solutions. Then we experimented with React PHP and actually landed to one of our galaxies in Manychat universe with the data partitioning. And finally, Nginx plus Lua that serves us well till this time, and we really have a lot of capacity in this solution even to expand like many times later. And I would like to end with this quote. So I believe the function of good software is to make complex appear to be simple. Actually, in real life, evolution beats revolution, I believe, one well-paced step at a time. And every challenge that Manychat that we had was this particular step towards the more resilient system that we have right now. Thank you.